Algebraic Reasoning, Chapter 2.1, Exercises 1 through 12. This Chapter 2 has to do with transformations of functions, and Section 2.1 has to do with transformation of linear functions. And in this exercise set, in this video, we're going to go over the odd number problems 1, 3, 5, 7, 9, and 11. For questions 1 through 8, describe the transformation of the linear parent function fx equals x that will result in the graph of the linear function given. So really what we're looking at is we have a parent linear function, which is going to be the equation y equals x, and I'm drawing that right here, a diagonal line, y equals x. And so we're going to be taking this function here and transforming it somehow, rotating it to a different slope, moving it up and down. Okay, that's what we're doing here. So let's take this one right here, h of x equals 4x minus 1. So we're taking this, we're changing the slope of this line from 1 of the original parent function to 4. So we increase the slope of the line from 1 to 4, and then our y-intercept is going to be -1, and change the y-intercept to -1. And so really, that's it. That's how we would transform. F of x equals x into the linear function given. Next, number 3. Same directive, but we're going to have this time the equation h of x equals 3x plus 2. And now we have a 3 outside the parentheses. And so if we distribute, we get 3x plus 2. And so what do we do to change, to transform the linear parent function? We increase the slope from 1 to 3 and increase the y-intercept from, what is the y-intercept in our original y equals x function? 0. From 0 to 2. And so that would describe our transformation. Okay, let's go to number 5. Same directive, but we're going to take this function here, h of x equals -3 fourths x minus 8 and plus 2. So we're going to take this -3 fourths times this x and this -3 fourths times this 8. Then after that, add 2. And so working to the right, we have -3/4 times x. And then we're going to have a minus minus, right? -3/4 times -8. So that's going to end up being a plus 3/4 times 8. And then we bring over this plus 2. And now working below, we're going to just start simplifying here. We have -3/4 x. So we know our slope is going to be -3/4. That's no mystery. Then we have 3 times 8 in the numerator. So plus 3 times 8. And let me just write what that is going to be. 3 times 8 is 24. Plus 2. And x plus 24 divided by 4 is 6 plus 2, and that's going to be -3/4 x plus 8. So that's going to be h of x. So what do? We change the slope from 1 to -3/4 and increase the y-intercept from 0 to 8. And that will be our transformation for problem number 5. Next, problem 7. And we're going to do the same thing as we did problem 5. We're going to distribute that 4, -4 to that 1/2 x, and that -4 to this -3. And then we're going to add the 2. So we have -4 over 2. So I'm just going to write -4/2 x. And then we have -4 times -3, which is going to simplify to plus 12. And we bring over this plus 4. And now working down, we have -4 over 2 is going to be -2x. And we have 12 plus 4 will be 16. So h of x is going to simplify to -2x plus 16. So what do we do to, let's describe that transformation. We change the slope from 1 to -2 and increase the y-intercept from 0 to 16. That's all we do in these transformations. We change the slope and the y-intercept. That's it. And so that's number 7. We're going to go on to look at number 9. And number 9 is part of an entirely new set for questions 9 through 12, identify the domain, range, x-intercept, and y-intercept of the linear function described by the equation in the graph. So here we get an equation and a graph. And let's see, the domain says write inequalities. Now, one thing we've done in pre-calculus sum is we write our domain as interval notation. And for a linear function, it's going to be all real numbers, which is greater than negative infinity, less than infinity. The range is going to be similar, not similar, but identical. Okay, greater than negative infinity, less than infinity. But to write these inequalities, domain is related to x values, so we have x is going to be greater than negative infinity, but less than infinity. So that's our domain. And I'm going to put D colon, and our range is going to be the same thing except for y. So y is going to be greater than negative infinity. Let me leave myself some more room here. I'll put y is greater than negative infinity, but less than infinity. Okay, the x-intercept, y-intercept, well, we have f of x equals 2x plus 3, so that's going to be easy. Our y-intercept is going to be equal to 3. And now for our x-intercept, what is that going to be equal to? Well, if our x-intercept is going to be what is the value of x when y equals 0? So if we take this f of x and set f of x equals 0, we say 0 is equal to 2x plus 3. We just go about solving for x. I'm just going to switch this around. 2x plus 3 is equal to 0. And we subtract 3, cancel out 2x is equal to negative 3. And if we divide by 2, we have x is equal to negative 3 over 2. Or we could say or negative 1.5. So I'm going to write over here x-intercept equals negative 1.5. So those would be our y-intercept and x-intercept. And then our domain and range would be these values here, boxing in inequality notation. Okay, let's go on to problem number 11. Okay, let's see. Our domain is going to be the same as we had for problem 9 because we have a linear function. There are no restrictions to its domain. So our domain in inequality notations would be x is greater than negative infinity while being less than infinity. And our range is going to be the same thing except for the variable y. That's our domain range. Now, for x-intercept and y-intercept, from the graph, if the graph is at all accurate, the y-intercept is going to be equal to 3, and our x-intercept is going to be equal to 6. And sometimes you can write these in coordinate pair. Y-intercept, you can write that as 0, comma 3, and our x-intercept you can write as 6, comma 0. So just a slightly alternative way of expressing x and y-intercept. But we don't really have this verified algebraically. But if we went and distributed this 4 over here and simplified, we probably could get somewhere. We have 4 times, I'm going to work to the right, 4 times -1/8, so we get -4/8 x, and then we have 4 times 2, it's going to be +8, and then -5 on the outside, so we're going to get -1/2 x, and then we have 8 minus 5 is going to be +3, and that's going to be f of x. And we can plainly see here that our y-intercept is 3, and if we set f of x equal to 0, we have 0 equals -1/2 x plus 3, and we subtract 3, we get -3 equals -1/2 x. And if we multiply by 2, bring this down, multiply both sides by 2, we get -6 equals -x. And working the, and rewrite -6 equals -x. And working to the right, if we divide by -1, we're going to have x is equal to 6. I don't know what's happening to me today. Okay. So x is equal to 6, which verifies what we have up here. Okay, that's going to be this brief video lesson. I hope this has been helpful to you. Good luck, and thanks for viewing.